Previously we learned to find the volume and surface area for any polygonal prism. Here we will see that regular hexagonal prism is a special case. For any other prism, any other regular prism like pentagonal or octagonal prism, to find this area of this one triangle, these triangles are isosceles triangle. This arm is radius, this arm is the arm length, this is the center, this is this center. We saw in our previous example that these two arms are equal, and which is equal to the radius of the circle that enclosed that polygon, and this is one arm, and we draw a perpendicular line which divides this arm into two parts, and from there we calculate this height, and thereby we calculate this area of this one triangle, and this area we multiplied by n to find the n-gonal polygons, say with 5 for pentagonal pentagon, or by 8 for octagon, and so on. Regular hexagonal prism, regular hexagon is a special case, where this is a hexagon 1, 2, 3, 4, 5, 6, where even these arms are equal for all polygons, all regular polygon, but for hexagon this arm is also equal. That is, for a regular hexagonal polygon, if we draw a triangle by joining the center and two vertex, then all these three arms are equal, and this is only true for regular hexagonal prism. So this triangle, this inside a small one triangle, then become a equilateral triangle. So to find its area, for example, here we need either this height and this arm length, or this arm length or this radius, or this height or radius. Any two of these three parameters must be known, but here only one parameter is enough, which is the arm length, because this all three arms are equal, and based on just this arm length we can calculate the area of this equilateral. This is an equilateral triangle, so based on just arm length, one arm length, we can calculate the area of this equilateral triangle, and thereby we can calculate the total base area. Let us do one example that will make us our concept clear. So this is a regular hexagonal prism. So that means all these arms are equal, and from center, if we draw these kinds of small triangles, then all these triangles, there will be six of them. So this 1, 2, 3, 4, 5, 6. So 6 of these triangles are equilateral triangle. That means if we bring it out as this, then this is an equilateral triangle whose arm length is 8. This is 8 centimeter. So now we need to find the area of one triangle, area of just one triangle. Then if we multiply by 6, because there are 6 of them, then we will find the total area of this base. So to find the area of this equilateral triangle, we will, similar to others, we will draw a perpendicular line, and this perpendicular line will divide these arms into two parts. So that means this part will be 4 centimeter, and this part will be 4 centimeter, and this arm, we already told that this is an equilateral triangle, that is, this total arm is 8, so this arm is also 8. So if we just consider this part of the triangle, this is the right angle, so its opposite arm is the hypotenuse, and if we consider this height is u, then this hypotenuse square, that is 8 square, will be this u square plus this 4, half of this total arm is 4, plus this 4 square. So from here we will get u square equals 8 square means 64, minus this is 16, so which will give us 48. So u equals square root of 48, and if we calculate it, then we will get, we will get this u as 6.93 centimeter. So now we got our height, and this total base is 8 centimeter. So the area of one triangle, area of one triangle will be half times its base is, total base is 8, and this height we just found 6.93. So if we calculate it, the base area will be this is one area. If we calculate it, let us calculate it. It will be half and 8, 4. So 4 times 6.93. It will be 27.72. 27.72 centimeter square. So one triangle's area is this, and this is an hexagonal base. So there are 6 of them. So the total base area, will be 6 times of this one triangle's area, that is 22.72. If we multiply it, we will get 166.32. 166.32 centimeter square. So this is the total base area. So this is the difference with other polygonal regular prism, that for hexagonal prism, giving just one arm is enough. From there we can calculate the height and thereby the area of this small triangle, and by multiplying it by 6 we can get this total base area. That is the only difference. Now the base perimeter. Base perimeter will be 6 times, because there are 6 arms. So each arm is 8 centimeter. So it will be 6 times of 8, which is 48 centimeter. We got our base area and base perimeter. Using the formula, we can find total surface area. We know the total surface area formula is 2 times base area plus base perimeter times height of the prism. So 2 times base area, which is 166.32 plus base perimeter, which is 48, times height of the prism. So here this is one hexagonal face, there is another hexagonal face here. Distance between these two hexagonal faces is 16 centimeter. So it is, height is 16. So if we do this calculation, the total surface area will be 1100.64. 1100.64 centimeter square. And the volume formula is base area times height. So now the base area is 166.32, and height is 16. We just used here. So if we multiply them, we will get 2661.12 centimeter cube.